Morning, everyone. I know that you're waiting to head off to coffee breaks now, but I've got it's great to be here and present on London Internet Exchange and our story around deploying a disaggregated network platform. I'm going to start off today and just talk a little bit about, first of all, recap on what links, what is links and what is an internet exchange. I'm going to talk about the technology that we deployed, and then I'm also going to speak about the process that we went through and the learning that we went through. So as far as links is concerned, we are one of the largest internet exchanges in the world. So there's three that are recognized and as probably the leading internet exchanges in the world, and links is one of them. And what do we provide? Well, an internet exchange is commonly known as an IXP, and we provide a neutral interconnection platform for our customers, our members, our customers and members to come together to exchange traffic. You could think of it as a stretched metro-wide Ethernet layer 2 domain within the city centres. Our members, probably many of you, in the room either use them or know them or maybe are our access networks, ISPs, and content providers from around the world. So our members consist of around 850 networks connecting into our exchange platforms from 80 different countries coming into them and exchanging. And they use the peering platform to exchange securely using BGP protocol to connect their networks together. So through links, you can reach around about 80% of the global internet routing table. We run on our main platform around about 4.5 terabits of peak traffic in the evenings, and we connect over 25 terabits of ingress capacity on our infrastructure, just to give you a feel for the size and the diversity of the network that we're talking about today. Now, we operate 2 internet exchanges in London. We also operate in North America. We have Manchester, for those that know the UK, Wales and Scotland as well. I'm going to focus today predominantly on talking about our London infrastructure. So those that hopefully know a little bit about London, it's a huge city. It covers 65, well, our network covers a span of 65 kilometres. So this is from the west of London with Equinix Slough, all the way over to the east of London with Telehouse in Docklands. We connect across 12 different locations. We don't run our own data centres. We partner with data centre providers, so Digital Realty, Equinix Interaction and Telehouse are our strategic partners in this, and we put our equipment in secure facilities in these 12 locations within London. So I'm going to talk today about London 2 infrastructure. So we have the 2 networks in London for diversity reasons, and this project, this open compute, our move to disaggregation is all about London 2 and the infrastructure that we put in. And I'm going to talk about the technology that we've invested in, and I'm going to talk a little bit about the process and the learning that we went through, because it's very different, not just for an IXP, but maybe for many service providers that are thinking about going into the open compute, open networking environment. So when we started this journey, it was actually back in late 2015, so it's quite a while ago, but I'm going to go through some of the timing so that you get an appreciation for the learning as we've gone through. But we had about 700 members at the time. We're now, as I say, over 825. Our current, what was then our London 2 network was starting to creak at the seams. It wasn't scalable, it was costly, it just wasn't going anywhere. So we wanted to make a change, and we wanted to invest in new technology. As we are a membership organisation, our customers are our members. We're very intimate and we're very close to the people that use the platform, our customers. So we went and did a review. Late 2015, we actually went back to the leading 30, the 30 members that we saw as significant participants on the platform, and we said, look, this is what we're thinking about doing. Effectively, ask for feedback from our customers. What do you think about going into open computing and open networking? And we got fantastic support. We thought it might be a little bit bold, a little bit too early in the process, but we got fantastic support, feedback from our customers, from the membership, and we approved a technical solution based on EVPN and open compute, open networking. That effectively meant that we had improved services that we could offer to the exchange, and also lower cost. So this is a bit of an unusual part of it then. So before we even deployed the network, we'd done a prototype, and we said, look, we think we can make it work. And because we're a membership organization, we said, look, we're going to pass on a 40% reduction in our pricing as a way of returning value back to the membership. So, because we don't have shareholders, effectively our mechanism for returning value back to our customers is through reducing our port prices. So we actually reduced 40% pricing in July 2016 ahead of us fully deploying this based on our confidence. How did we achieve this? Well, we picked two strategic partners. I think one of them's here at the event today, EdgeCore Networks, part of the Acton Group, and also IP Infusion. And I'm going to talk a little bit more about their role and the role that they had to play in the process. But essentially, EdgeCore Networks are the company that make the networking devices that we put out into those data centers that I mentioned. IP Infusion are the company that make the network operating software that runs on those devices and that also talks up to the Lynx network configuration system that we've deployed in our infrastructure. So two very strategic partners. Within that whole ecosystem, we also had Sienna for the data center interconnect. We had Finisar for the optical interfaces as well. So there's more players in the whole environment, but the two that I really want to focus on today is IP Infusion and EdgeCore. So once we sat down at the end of, I think, probably about February 2016, we decided February, March time that we would go ahead with this. We were going to go ahead with EVPN, which is an Ethernet VPN solution, very much geared for a distributed layer 2 network. We were going to adopt a leaf and spine architecture. We were going to integrate it with our network configuration toolset, and we were also going to make it 100 gig capable to deliver for our membership. So this then meant that Lynx would be the first internet exchange in the world that would adopt these technologies and deploy them into a production system. So before I get into the timeline and talk a little bit about the journey we went through, just quickly over the technologies that are involved in this, because I've mentioned a few of them. The main thing that we started with was the architecture. So we borrowed really from the data center web scale companies this leaf and spine architecture, and we went from a single chassis multi-slot architecture to a top of rack type 1U leaf spine architecture. Why did we choose that? Well, it was just the right, from an architectural point of view, it was the right size, the right fit for Lynx's environment. It's really down to the environment you're deploying the hardware into. We feel that it gives us a lower complexity and also helps us to isolate failure domains. What does it look like in the physical sense? The typical large system deployment is like a multi-slot chassis, shared fabric, and what we're moving to is more of a leaf and spine architecture where the fabric effectively becomes the spine and the leaves are role-based devices for either connecting 1 gig, 10 gig, 100 gig, whatever we need to interface with the members. We then said, right, okay, well, we're happy with the architecture. Now, what about this disaggregation? So we didn't want to just go and buy a normal label switch or routing device. We went for this disaggregated approach. So this was taking the generics or the normal networking device and going to a white box vendor such as EdgeCore and say, well, look, we want to take your hardware with your silicon, or in this case, Broadcom silicon, running within your hardware. We want to take this operating system and we want to get the best elements of the two and merge them together. So this was a bit of a learning curve for us, but it's been demonstrated for many, many years within the data centers. So the big web scale companies have been doing this within the data centers. Typically, they normally have large software development teams that can write their own network operation system, or at least write big parts of that to plug into their automation and orchestration engines. Lynx doesn't, we're a small company. We don't have that capability or that luxury. So we had to partner with as I say, IP Infusion to help us do that. But I think longer term, being able to pick independently between the different silicon chipsets that were in the devices, the physical device itself, and the network operating system, allowing us to pick them independently, as well as the optics that plug into these boxes, gives us real value for the long term. So it means that we can be much more selective. The second area, or sorry, I should say the third area, so after the architecture and then also the actual physical technology that we picked, was to then say, well, we want to run EVPN. So EVPN has huge benefits for an internet exchange, but also if you're running a distributed layer 2 network, effectively everything is programmed. What this means is it uses multi-protocol BGP, so it uses the control plane to actually send information about MAC addresses around to the network. So there is none of this unknown destination where you would broadcast and flood traffic through your network. Effectively, everything is synchronized through the devices communicating with each other, and everything is known. This means it's much more stable network, it's much more robust. If you think about a huge Ethernet network stretched across 65 kilometers with dark fiber and 12 different locations, this brings huge benefit to that type of environment. The other area is it brings some added features. So the fact that the MAC addresses are programmable, you can add things like multihoming. So multihoming is a great mechanism, whereas before, today, if we have a customer that's taking 2 times 100 gigs to connect into our network for interconnection, they have to be on the same device. Whereas with multihoming, it means that you can actually plug multiple 100 gigs or 10 gigs into the network across as many endpoints, physical locations as you want, and you can virtualize them into a single reachable endpoint. Now, the internet is always on. It's always a challenge for us when we're trying to do maintenance. So this is a great feature for us to be able to take down parts of the network and then move seamlessly across to a different location, either through a planned maintenance or through unexpected maintenance failure, unplanned failure. So what is about the process? I mean, those that have looked into open computing and open networking will probably know that there are some complexities to this. We did a demonstration phase back in 2016, so this is when we decided to reduce our pricing. And we had the vendors come in, or the EdgeCore and IP Infusion come in and do a demonstration phase. At this stage, IP Infusion hadn't really deployed EVPN in any kind of anger, so this was a real new one for them. But on the back of the demonstration phase, we were confident in picking the partnerships, and I would say part of the success in this journey is picking the right partnerships, working on a collaboration approach, getting very close to the vendors or the suppliers that you're working with and trying to integrate them into your core team so that you've got a very open and transparent working model. I think, without that type of approach, we wouldn't have been successful in this journey. So once we'd once we'd demonstrated, we went into a prototyping phase. We started to deploy EVPN actually over MPLS as an underlay, and we ran into some roadblocks on that because of the way that Links operates, the architecture of the way that we operate. It meant that the MPLS didn't scale for us. So we then converted to VXLAN, so EVPN over VXLAN. It meant that we added some time into the process, but by the end of, I think mainly all the way through, by the end of the summer of 2017, we were in a good position. So hardening phase, well, this is when we felt that we needed to get GA code from IP Infusion. So this is getting rid of all the bugs, doing all of the various testing around the world. This was a very interesting stage as well because actually we don't have a single location that we can go and do a nice proof of concept and then tick all the boxes that everything passes. This is one company in India, another company in Taiwan. Links is based in London. It's the 3 companies working together, creating a virtual proof of concept, round-the-clock testing, QA of software on a continuous basis. So it was a big learning curve for us, but it worked, I say, really, really well. We utilized, obviously, technology to bring the 3 teams together. We shared test plans, and obviously we shared both the ups and the downs on this. Then when we went into deployment phase, so early 2018, we started to deploy this into the network once QA had been done. Everything went really well, running parallel, so this is all the dark fiber, all the links that were put in, the equipment, the software, integration into our software automation stack, and then we migrated all of our customers over during the April-May time, and it's been live, fully operational since June. And well, I'm certainly pleasantly surprised by the small number of issues that we've had on it because it's performed really, really well. There is a final stage that we're going to do, which is an enhancement phase. So IP Infusion had created a special branch in their software for links. That gets merged back into the main chain of software now in the next month or so, and we're going to take that on board because we don't really want to have a special branch in anyone's software development cycle. Then just to really conclude and finish off in the last couple of minutes is just to reflect on what does this mean back to the membership and what did it mean for us as far as learning. Links is one of the top 3 internet exchanges in the world, so we are very visible. So it was a key strategic project for us. Our members, 850 members, all of the big service and content providers you can imagine from around the world, connecting to our exchange. So very visible if this goes well or goes wrong. Having 2 LANs in London meant we could be a little bit bolder maybe than others that don't have that facility. And certainly when we consulted our members, that's the message that we got back. It means for the small networks, this EVPN technology means that we get rid of all that broadcast traffic. It's a much richer experience for them. And for the larger networks, because of the cost, because of the flexibility, the multi-homing, it means that we have a much more robust and scalable network that we can offer to them. And finally, we approached this with 100% automation in mind. We could not have moved the hundreds and hundreds of customers over in the 2 months that we did without proper automation scripting. We don't buy an off-the-shelf. We build our own. The NCA acronym there is the Network Configuration Automation Platform. We use Juniper, we use Palo Alto, we use EdgeCore, we use multiple vendors across our network, and at the moment we have a deployment stack of network automation, which really is a Links SDN type of approach. So, that brings me to the end. I know we don't really have a lot of any time for questions, but it gives you a little bit of a taste. If obviously you can find me on LinkedIn if you've got any questions or you've got anything you want to follow up on around open computing and open networking in our experience. Please do look me up on LinkedIn. Thank you for your time. Thanks.
Thank you, Richard.